Hi, Mr. West. This is my final CPT recording, and I decided to do question 2 on time dilation. So this one was completely new to me, and I actually had a lot of fun solving it. So the question gives me a speed of an aircraft, which is a percentage of the speed of light, 60%. It gives me dilated time, which is the time that the observers in the spacecraft see. Obviously, we know the speed of light. And so for A, it asks me for the proper time. And the formula we're going to use is the time dilation formula. I always like doing a D to represent dilation and an R to represent real. Obviously, people can do it a little bit differently. That's just my personal preference. So it asks for the proper time in hours. That is this part of the formula. So we're going to rewrite the formula as time dilation times the root of 1 minus speed squared, the speed of the craft, divided by the speed of light squared. And that is going to be equal to real time. And so to solve this, dilated time we know is 24 hours. Sorry, I'm leaving it in hours because the question also asks for hours. And the meters per second will cancel out for the speed of light and the proper speed. So 24 hours times the root of 1 minus 0.6 c squared divided by c squared. So something that messed me up originally was you factor out the c here and not the c squared term. So now this turns into 24 times the root 1 minus 0.6 squared. And this is your real time. And that ends up equaling, sorry, I already have it just calculated for you, 19.2 hours. That's the exact value. It isn't rounded. So, oh, excuse me, messed up there. Time real. So obviously we can write in a therefore statement, even though this question has two parts. Therefore, the time between the two events on Earth was 19.2 hours. Okay, so part 1 is done. Now we're going to go on to part 2. It now asks for the dilated time if the craft is now moving at 95% the speed of light, which is really fast. So we have our real time, our Earth time, that was observed for between the two events. It never specifies them. So we're going to apply the same formula again. So dilated time. I can obviously include the delta, but that isn't really necessary here. It's equal to real time divided by the root 1 minus your speed squared divided by the speed of light squared. And so now I'm solving for dilated time. So I'm literally just going to plug everything into this. And we're going to apply a real Earth time into this formula because now we know how far apart the events actually took. So we're going to write 19.2 divided by the root of 1 minus 0.95 c squared divided by c squared. And so factor out the c here. This turns into 1 squared, which is 1, and 1 is in every denominator for everything, so it doesn't affect anything. So it's your final term is going to look like 19.2 divided by the root 1 minus 0.95 squared. And that is equal to 61.4892110.6 hours. So this question also, I believe it's specified in hours. It doesn't actually say, but I've just left it as hours. So I hope that is okay with you. Obviously, I can change it into seconds or minutes. And using significant figures, we're going to round this to 3 numbers. And 9 and 8 both round up. So this is going to be 61.5 hours. So that's what that's how long it would take for the crew to observe between the two events if they're traveling at 95% the speed of light. And now obviously at the end, we just want to say it would be seen at 61 and a half hours. So that's it for me. I hope this is all good for you. I actually had a lot of fun with this question, and I'm glad you included this. That's it. Thank you.